Infrared or infrared band is a band of the electromagnetic EM spectrum that has shorter wavelengths, roughly 700 nanometers to 1 millimeter, i.e. sub-millimeter, but higher energies, i.e. sub-millimeter radiation, and higher frequencies, roughly 300 gigahertz to 430 terahertz, than those in the radio band. So in other words, infrared is a band of the electromagnetic spectrum that has shorter wavelengths but higher energies and higher frequencies than those in the radio band. So let's take a look at the electromagnetic spectrum. And we want to focus on the infrared band. So the infrared band is located right here. We're at the very edge of the visible band. So you see some red in the infrared portion. But in general, objects that emit in the infrared, you can't see those light of infrared with your eyes. For example, your human body emits in the infrared band. If you were to go into a room and turn out all the lights so there's absolutely no lights in the room, you wouldn't be able to see yourself glow in the infrared because you emit no visible wavelengths of light. So the infrared portion is just at the edge of that radio portion of the visible band. In fact, this edge of the infrared band, the one that's closest to the visible band, is called the near infrared, otherwise known as NIR, N for near, IR for infrared, whereas the other side, the side closest to radio, is called the far infrared. F for far, I for infrared, R is the red portion of the infrared. So you got the far infrared on the left side, or the longest wavelength side of the infrared band, and you have the near infrared on the shortest wavelength side of this infrared band, which is in between the radio band and the visible band. So now this band is noted for having shorter wavelengths than the radio band. So notice the radio band here has very long wavelengths, and notice that they get shorter. So the distance from peak to peak gets shorter in the infrared band compared to radio. And thus we have higher frequencies. If you notice, the frequency value increases. So now the numbers are getting so large, we're getting into this 300 gigahertz to 430 terahertz. Tera is 10 to the 12th. It's a very large number, to the point now that it makes no sense to start talking about frequencies in these higher bands. And then we just switch. Instead of talking about frequencies, we talk about wavelengths because they make more sense. So wavelengths are in nanometers to less than a millimeter, i.e. sub-millimeter. We're less than a millimeter, so we're looking at sub-millimeter wavelengths, and hence the symbol or the icon for the infrared is a needle. So the thickness of a needle would be a sub-millimeter length of wave. Now we're also getting into these higher frequencies, therefore the energies are getting higher. We have a higher radiation type than the radio band. This defines the infrared band.